Now we'll continue the urns and balls questions with a few more about it. Let's refresh our memory. We're saying we have 100 balls and 100 urns, and we're just with each ball, we put it in any of the 100 urns with 1 over 100 probability. It doesn't matter how many balls are in each urn. Every time we grab one of the balls and it goes in each urn with an equally likely chance. So what is the chance that a total of exactly 5 balls are placed in the first 3 urns with at least 1 ball in each of the 3 urns? So what do those sequences look like here? So we could have 1, 2, 3, 2, 3, say, and then let's just call it other. So let's just call it no, and then no. So I have 95 of these. 95 of these. So the chance of getting this particular sequence, well, this is 1 over 100. This is 1 over 100, and so on. But each of these, because we've lumped all of the other ones together, so we could have urn 1, urn 2, urn 3, and then all of the others. So the chance of getting here is 97 over 100. So any sequence where we look at this, where 1, 2, and 3 are distinct, but all of the others are lumped together, we have the chance of that particular sequence, so the chance of that particular sequence, anything that looks like this, is 1 over 100 to the 5th, right? Because we put 5 of them in urns 1, 2, and 3, and we have 97 over 100 to the 95th, right? Because these are other urns, and these are 1, 2, or 3. Now, the next part is to count how many possible ways there are to do this. So, how many ways are there to pick a sequence? So, how many sequences? How many sequences? And let's just use a particular number as an example with 1, 1, so 1, 1, 2, 2s, and 2, 3s. So, this satisfies our constraints. So how many ways are there to do this? We could pick, well, we have 100. Choose 1, 2, 2, and then 95, right? And this is for this particular sequence. So now this is with this count. So now what if we had 2 1s, 1 2, and 2 3s? Well, that would be the same quantity. And if we had 2 1s, 2 1s, 2 2s, and 1 3, it would also be the same. So for that, we have 3 times this. So the number, let's start counting the number of sequences. The number of sequences is 3. So 3 times 100. Choose 2, 2, and 95. It doesn't matter the order I put them in down here because it's still going to give you the same number. 2, 2, 95, 1, plus, because there's going to be something else, because there's another case, right? There's another case where I have, say, 1, 1, 1, 2, and 3 3s. And this is 100. Choose 3, 1, 1, 95. And again, we can do the same thing. We can get 3 of the 2, 3 of the 1, and so on. And they're all different sequences. So we have 3 times 100, 3, 1, 1, 95. Because, so these are, let's scroll down. So these are sequences where we have 2, 2, and 1, or it doesn't matter what the numbers are. And these are sequences with 3, 1, and 1. So to find the actual probability, all you have to do now is multiply the number of sequences times the probability. So let's call this whole guy n. This is n, and this is p. So we're just going to multiply together n and p. It's the number of sequences times the probability of each. Now let's do part D. Well, D says, what is the chance that a total of 5 or less balls are placed in the first 3 urns, with at least 1 ball in each of the first 3 urns? Well, you can only get 3, 4, or 5. So we could have 3 balls. There's cases, 3 balls. We can have 1, 1, 1, 2, and 1, 3. 4 balls. We could have 1, 1, 1, 2, and 2 3s, for example. And we did 5 up above. 5, C above. C above. Okay, so how many ways are there to get a sequence like this? Well, this would look like 1, 2, 3, and then no 90, sorry. Yeah, 1, 2, 3, then no 97 times. This could look like 1, 2, 3, 3, and then no 96 times. So the number of ways to choose this, we have 100 balls, and we want to pick 1, 1, 1, 97. Here we have 100 balls, and then, yeah, here we have 100 balls, and we want to pick 1, 1, 2, 96. And note that there are still 3 ways to do this, because we could have 3 get the 2, 2 get the 2, or 1 get the 2. So there's 3 possible sequences here. So just like above when we called this n, we have n equals this for 3, and 3. Let's call this n4. So these are the number of possible sequences. And what are the probabilities for each of these sequences? Well, the probability for each of these sequences is just, well, we have 3 in one of the 3 urns, and the probability of each of those urns that it hits is 1 over 100. So there's to the third. And then the probability of getting in any one of the other urns is still 97 over 100. And except that's to the 97 this time. And here we have 4 times where we hit one of our 1 over 100 urns. Each of these sequences has probability 1 over 100, because this contributes 1 over 100, this contributes 1 over 100, so does this, so does this. And each of these contributes 97 over 100. And so this is to the 4th. And in this case, this is to the 96. So all we have to do now is add up the possibilities from above and from here. So all we do is we take n3p3 plus n4p4 plus n5p5. And why can we do this? It's because all of these events are mutually exclusive. If I got exactly 3, I can't have had 4 or 5. If I got exactly 4, I can't have had 3 or 5, and so on. So I just compute the probability of each of these events, and I add them together, because mutually exclusive. Mutually exclusive.